The Internet Computer, commonly known as ICP, is a groundbreaking blockchain protocol developed by the DeFi Foundation that seeks to fundamentally transform the Internet by enabling the hosting of smart contracts, decentralized applications, and even entire websites directly on the blockchain itself, creating a truly decentralized world computer. This innovative approach eliminates the need for traditional centralized servers and cloud services dominated by big tech companies, and it's gaining renewed attention in 2025 due to its advancements in decentralized AI hosting, seamless blockchain integrations like chain fusion with Solana, and the growing ecosystem of canister-based dApps that promise web speed performance and infinite scalability. In this comprehensive video, we provide an in-depth educational analysis of ICP's core technology, including its canister smart contracts and subnet architecture, its tokenomics with the ICP utility token and reverse gas model, the latest updates such as improved storage and chain key cryptography adoption, and the overall progress of its developer ecosystem. Please be aware that this entire video is intended strictly for educational purposes to help you understand the concepts behind ICP, and it should not be interpreted as financial advice in any way. We strongly recommend consulting with qualified professionals before making any investment decisions. Throughout this discussion, we will explore in detail what the Internet Computer truly is, delve into its tokenomics and market fundamentals, examine its mission and real-world use cases like decentralized AI and DeFi, review recent developments and emerging 2025 trends, address potential risks and considerations, and finally, outline the future outlook with key milestones to watch. At its core, the Internet Computer represents a revolutionary decentralized computing network meticulously built by the DeFi Foundation, designed to empower developers worldwide to host a wide array of software applications, sophisticated smart contracts, and even complete, fully functional websites directly on the blockchain without any dependency on centralized infrastructure. This on-chain hosting capability is powered by advanced technologies like WebAssembly modules and canisters, ensuring high efficiency and security, while features such as chain key cryptography enable near-instant transaction finality and secure interactions across multiple blockchains. The magic behind this seamless on-chain functionality is achieved through canisters, which are highly advanced smart contracts that elegantly bundle both executable code and persistent state data into self-contained units, thereby completely eliminating the reliance on any external centralized servers for processing or storage. Importantly, ICP operates as a true layer, one blockchain protocol in its own right, providing the foundational infrastructure rather than merely serving as a token layered on top of another network like Ethereum, which allows for infinite scalability via dynamically spawning subnets and supports a reverse gas model where developers prepay for resources in cycles, freeing end users from transaction fees. What sets ICP apart in the crowded blockchain landscape are its standout unique value propositions, including lightning-fast web speed execution of smart contracts that rivals traditional web applications, virtually infinite scalability achieved through the innovative subnet technology that automatically adds computing power as demand grows, and a pioneering reverse gas economic model where users enjoy fee-free interactions because developers cover the computation costs upfront via cycles. These features collectively position ICP as a potential game-changer for building scalable dApps, from AI inference to complex DeFi protocols, all while maintaining robust security through the network nervous system governance. The ICP token serves as the lifeblood of the entire network, playing a pivotal role in powering all computational activities, facilitating decentralized governance decisions, and providing the essential cycles that act as the fuel for running canisters, storing data, and processing transactions across the subnets. Token holders have the opportunity to actively participate in the network's evolution by staking their ICP into neurons, which grants them voting rights within the Sophisticated Network Nervous System, or NNES, a DAO-like structure that democratically decides on upgrades, parameter changes, and resource allocations, often rewarding participants with additional ICP for their contributions to governance. In terms of tokenomics, ICP tokens are dynamically minted to incentivize and reward active governance participants who vote through the NNES, as well as node providers who maintain the decentralized hardware infrastructure, ensuring the network's reliability and uptime. Conversely, tokens are burned, permanently removed from circulation, whenever they are converted into cycles to cover the costs of computation, storage, and bandwidth usage, which introduces a balanced mix of inflationary rewards to encourage participation and deflationary pressures to promote efficiency and long-term value stability based on actual network utility. Ultimately, the Internet computer's grand mission is to establish itself as a fully decentralized and serverless cloud computing alternative to the likes of AWS or Google Cloud, capable of natively hosting a diverse range of decentralized applications or DApps, sophisticated AI models for inference and training, immersive blockchain-based games, robust DeFi protocols for lending and trading, and even open internet services that prioritize user privacy and control. By leveraging canister technology and chain fusion, ICP enables these applications to interact fluidly with other blockchains, fostering an interconnected Web3 ecosystem free from single points of failure. A key pillar of ICP's vision is the emphasis on true data sovereignty, empowering users and developers to maintain complete ownership and control over their information without the risks associated with big tech centralization, where data is often exploited or censored by corporate gatekeepers. This focus has fueled a compelling narrative in 2024 and into 2025 around decentralized AI hosting on ICP, where AI models can run tamper-proof on-chain, ensuring model integrity, data confidentiality, and resilience against shutdowns, making it an attractive platform for AI-driven DApps in fields like healthcare, finance, and creative industries. Among the most exciting recent developments shaping ICP's trajectory are the substantial growth in the number of canister-hosted DApps now live on the network, ranging from social platforms to NFT marketplaces, alongside a marked increase in its utilization for decentralized AI inference tasks that process complex computations securely across subnets. Furthermore, the developer ecosystem is expanding rapidly with new tools, SDKs, and resources becoming available, attracting more builders to create innovative applications. All while integrations like the advancing chain fusion with Solana open up cross-chain possibilities without vulnerable bridges. On the technical front, ICP has rolled out several key upgrades that are significantly improving aspects like long-term storage capacity for large datasets, enhancing overall scalability to handle higher loads without performance degradation, and optimizing subnet performance for faster and more reliable execution of canisters. These advancements are complemented by the continued widespread adoption of chain key cryptography features, which enable secure, threshold-based signing for multi-chain interactions and deeper integrations with prominent blockchains such as Solana, broadening ICP's interoperability and appeal in the broader crypto landscape. While ICP holds immense potential as a foundational technology for the future internet, it is not without notable risks, including the inherent technical complexity of its canister and subnet architecture, which can pose steep learning curves and development challenges that may hinder widespread mainstream adoption among developers accustomed to simpler platforms. Additionally, ICP faces stiff competition from well-established layer 1 blockchains like Ethereum, Solana, and Polkadot, each with mature ecosystems, larger developer communities, and proven track records that could overshadow ICP's innovations unless it accelerates user growth and real-world utility. For ICP's long-term sustainability and success, much will hinge on fostering continuous developer growth through better incentives and tooling, alongside building genuine user demand for its unique on-chain services like AI hosting and DeFi, all while navigating the unpredictable waters of regulatory scrutiny in the crypto space and broader macroeconomic uncertainties that affect market sentiment. As always, we urge viewers to conduct their own thorough research and meticulously verify all sources and information before engaging with any blockchain project, ensuring informed and responsible participation in the evolving world of decentralized technologies. Looking ahead, The future outlook for ICP in 2025 and beyond appears promising with the anticipated expansion of its decentralized AI hosting capabilities, allowing for more sophisticated on-chain models that integrate seamlessly with real-world data feeds and user interfaces. This will be accompanied by the growth of open internet services that democratize access to computing resources, alongside the emergence of new canister-based applications in gaming, social media, and enterprise solutions, potentially driving exponential adoption if execution remains strong. Among the key milestones worth monitoring closely in the coming year are major network upgrades aimed at further enhancing security and efficiency, the strategic expansion of subnets to accommodate surging demand from AI and DApp workloads, the release of innovative new tooling and developer kits to lower barriers to entry, and any potential evolutions in governance through the NNES or protocol-level changes that could introduce fresh features like advanced chain fusion integrations. The Internet Computer undeniably stands as one of the most ambitious and visionary projects in the entire blockchain space, with its bold aim to rebuild the Internet from the ground up into a decentralized, tamper-proof, and user-centric architecture that redefines computing as we know it. Ultimately, whether ICP achieves this transformative success will depend on securing real, tangible adoption from users and enterprises, cultivating sustained developer traction through its ecosystem, and demonstrating flawless long-term execution amid the competitive and regulatory challenges of the crypto industry. Thanks for tuning in to another Crypto Trend Labs breakdown. Just a heads up, we earn commissions when you use the links below to make purchases. It doesn't cost you anything extra, but it helps us a lot, so if something catches your eye, feel free to check it out. Likes, comments, and subscriptions also mean the world to us, and we'd love to hear your feedback. Remember, this video is for educational purposes only and not financial advice. Always do your own research.